started recording. I have started recording of this session. So after completion of this class, you will get this recording as usual in our departmental YouTube channel, TINT-IT Virtual Classroom, for your further clarification. Okay, so in our past class, last week classes, we have discussed about the viewing pipeline in 2D computer graphics, 2D visualization. So, as a very quick briefing about the last day discussion, that is, viewing pipeline is nothing but a serialization of some particular process by which we can render any scene. We can render any scene or any frame over the screen or over the monitor or over the output device according to the world coordinate to viewport coordinate transformation. So world coordinate is our superset. The world coordinate is our actual frame, which is consisted of all the objects which we can see. And viewport coordinate is basically the device coordinate through which we are going to render this frame or this scene, okay, which is basically a subset of this world coordinate. So now how we can convert this world coordinate frame to viewport coordinate according to the device coordinate, that is basically viewing transformation or viewing pipeline, what we have discussed in our last class. So today we will start with the clipping operation. The clipping operation. Clipping operation is, from the name you can guess that the clipping operation is a particular technique by which we can truncate or we can omit the outside portion of a scene which is beyond our viewport or device coordinate system. We can truncate or we can omit that part of the scene by this clipping operation or clipping technique. This clipping operation is used in so many processes like painting and drawing, 3D simulation, or rather world coordinate to viewport coordinate transformation. In all of these processes, this clipping technique or clipping operations is widely used. So again, I am sharing a notes to continue this class. According to these notes, we will explain how this clipping operations is taking place and what are the algorithms are involved for this clipping operation or clipping technique. So let's share the notes with you. After completion of this total module of 2D viewing and clipping, as usual, I will share these notes in your total notes in your Schoology platform, in your course account. From there, you can get these notes, you can access these notes. Okay, so now I am going to share these notes. Okay, all of you can see the notes. All of you can see the notes. Hello. All of you can see the notes.
No, sir. No, sir.
Okay.
Yes,
so,
sir.
Okay, so just wait for a few seconds. As you already know, Microsoft Teams has some delay. So that's why I think you can't see the notes. Just wait for a few seconds. I think it will be visible to you also.
Yes, sir. It is visible.
Yes. It is taking, Microsoft Teams has some delay. So it is taking some few seconds to notes or any kind of whiteboard, this can be visible to the students. It will take some few seconds. That's why. Anyway, every one of you can see the notes. Anyone left? Anyone is there who can't see the notes? Okay, all of you, I think can see the notes now.
Yes, sir.
Okay. So as you can see here, this is basically the clipping operation described by these two images. You can see here there are two side-by-side images depicted in these notes. One is window coordinate or word coordinate, whatever you can say, and another is viewport coordinates. So this red colored frame in both the images, the red colored frame is basically the system coordinate, like window coordinate or viewport coordinate. Okay, and the blue colored shape is basically the object which is going to be rendered in this window coordinate or viewport coordinate. Now as you can see here, some portions of this shape or some portions of this object is outside of this window coordinate or viewport coordinate in both the images. So these outside portion of this object should not be visible to the user or should not be visible to the viewer. Okay, so this outside part should be truncated, or this outside portion of this object should be omitted. So here we need this clipping operation. As you can see here, clipping algorithms procedure that identifies portion of the picture either inside or outside specified region. Procedure that identifies portions of the picture. It means that here, as you can see, this blue colored object, it has some portions here which are outside of this frame, of this red colored frame. Here in this window coordinate also, and here in the viewport coordinate also. There are some portions of this object which is outside of these frames, of this red colored frame. This red colored frame is our visible region, or rather our specified region. So any portion of the object or of the scene or of the frame or of the picture, image, whatever you can say, any portion of the image which is outside of this specified region or the visible frame, okay, that portion should be clipped, that portion should be truncated. So that's why these clipping operations or clipping techniques are required. Okay, so now application, you can see here the application of clipping: extracting part of defined scene for viewing, as I have shown you; identifying visible surface in a 3D view, what I have said, 3D simulation; anti-aliasing line segments or object boundaries; creating object using solid modeling procedure, that is again a 3D simulation process; drawing and painting operations. All of these are basically the real life or practical life application areas of clipping operation. Now this is the overview of this clipping operation, how this clipping operation is taking place, or what is the features of this clipping algorithms. So clipping operations basically maintain two approaches. One is clip world coordinate, that is only contents of the window interior mapped to device coordinates. It is nothing, basically the transformation between window or world coordinate to device coordinate or viewport coordinate system. And second approach is map all world coordinates to device coordinate, then clip against viewport boundaries. That is what I have just shown you right now. As you can see here, the first image is according to the world coordinate or window coordinate, and the second image is for viewport coordinate, it is transformed from window coordinate to viewport coordinate. As you can see here, all the frames and all the objects shown here has been scaled, has been transformed according to the coordinate system of viewport or device from window or world. This transformation has been discussed in our last class. You can recall that. Okay. So now, first we will start with the basic clipping algorithm, that is point clipping. Point clipping algorithm. First we will start with the point clipping algorithm, as because if we can clear out this point clipping algorithms, using this point clipping we can apply this to any kind of complex or combined geometrical shapes, like any complex type polygons or any irregular shape also. So point clipping is the basic or the naive algorithm for clipping operation or clipping technique. So as you can see here, first we have started with rectangular clipping window. Rectangular clipping window means our frame, that is the specified region in respect to which we will apply our clipping operation. That specified region or the specified frame is basically considered as a rectangular in shape. That's why it is called as rectangular clipping window. So now let's assume a point P with a coordinate xy. Okay. With a coordinate xy. So when this point P will be visible to the user or will be rendered over the screen so that it can be visible to the viewer. When this point P will be visible to the viewer, just tell me. You can understand. You can solve this. It is not a very big problem. My question is that I have given you a point P with a coordinate xy, and our frame or our coordinate or our specified region is xwl, xwh, just like our previous class. You can recall our previous class. Xwl is lower x coordinate for window, xwh is higher x coordinate for window, and YWL is lower y coordinate for window, and YWH is higher y coordinate for window. So your specified region is XWL, XWH, YWL, YWH, and my given point is P with a coordinate value XY. So now tell me what will be the condition so that P can be visible within this window frame. Tell me, any one of you.
X should be less than or greater than XWL,
Yes.
and
That means that is already shown here. That is, as you can see here, that is X should be within the range of XWL and XWH, and Y should be within the range of YWL and YWH. If X and Y are in between these two limiting value of X coordinate and Y coordinate, then we can normally say that the point P with a coordinate value XY will be completely visible and will be within this window coordinate region. Okay, so that it will be visible to the viewer. Okay, so this is called point clipping. It is, so the basic idea is that the coordinate values of your specified rectangular region, the coordinate values of the axis points, the coordinate values of the axis points of your rectangular specified region will be given to you, and according to the given point like P, you have to decide that the coordinate of P is within the range of the axis point coordinate of that rectangular specified region or not. If it is within that specified rectangular region, then the point is inside the frame and it will be visible to the viewer. And if the point is outside of the range of this axis point of that rectangular specified region, then the point is outside the frame or outside the window and it will be not visible to the viewer. So that is the simple logic of point clipping algorithm. Now, is it clear to all of you? Is it clear to all of you?
Yes, sir.
Okay. When I will ask you that it is clear or not, please respond. Otherwise, I can't get any. If I do not get any response from you, it will be difficult for me to proceed further. Okay. So when I will ask you that, is there any query or is there any problem or is it clear to all of you? Just respond to my query.
Yes, sir.
Okay. So now we will go for line clipping. Point clipping has been done. Now we will go for line clipping. So we will start with the basic and naive algorithm for line clipping technique. As you can see here, there are two images. One is before and another is after. So before means before applying the line clipping algorithm, and this is after the application of line clipping. As you can see, this rectangular specified region, this rectangular frame is our window, and there are 10 lines, and there are 10 number of lines are shown here. Not 10 number of lines, 10 number of axis points are there. So five number of lines are shown here. One is P1, P2, another is P3, P4. Third one is P4, P5, P6. Fourth one is P7, P8, and the fifth one is P9, P10. So there are 5 lines, 5 straight lines are there. You can see some of these lines like P1, P2 is completely inside the window, as you can see here. The line P1, P2, this straight line is completely inside the window. So it will be completely visible to the viewer. And some lines like P5, P6, P7, P8, like these two straight lines, some portion of these lines are inside the window and other portion of these lines are outside this frame. So to the viewer, only for P5, P6 and P7, P8, only that portion which is inside the window frame, that will only be visible to the user. The other portion of these lines is outside the window, so it will be clipped. It will be truncated. It will be not visible to the viewer. As you can see in the after image, the complete P1, P2 straight line, the whole P1, P2 straight line is visible to the user because it is completely inside the window frame. A selected portion of P5, P6 is visible to the user because these portions are inside the window frame. As you can see in the after image, P5 is converted to P5 dash P6. Now the straight line is P5 dash P6 because P5, some portion of this line has been clipped or truncated. Just like that, P7, P8 has been transformed into P7 dashed, P8 dashed, because some portion of this P7, P8 straight line is again clipped or truncated. And two straight lines like P3, P4 and P9, P10, these two straight lines are completely outside of this window frame. These two straight lines P3, P4 and P9, P10 is completely outside the window frame. That's why in after image you can see there is no trace of these two straight lines. There is at all no trace of these two straight lines. These two straight lines are completely clipped out or completely truncated. So using these two images, you can see here there are three types of visibility. There are three types of visibilities in clipping operations we have. So what are these three types of visibilities? Can you tell me? Anyone can tell me what are these three different kinds of visibilities we have? Anyone? Anyone can tell me what are these three different visibilities we have here? According to the condition, what are the three different visibilities? Any one of you?
Partial visible.
Can't hear you clearly. Please tell me.
Partial visibility, fully visibility, and
Who is it? Hello, who is
Anu,
answering?
Anukhi.
Anoki. Anoki.
Yes, sir.
Okay. What is your answer? Please tell me again.
Partial visible.
Completely visible. Yes, completely visible. That is absolutely correct. Completely visible, which is completely inside the window frame. Next one.
The partial.
Exactly. Absolutely. Partial visibility. That is like P5, P6 and P7, P8. Like these two straight lines, a particular portion which is inside the window frame, that portion will be only visible to the viewer. That is called partial visibility. Absolutely correct. And last one,
Don't know, sir.
yes, tell me.
Don't know.
The last one is completely invisible. That is P3, P4 and P9, P10. These straight lines are completely outside the window frame. So it will be at all not visible to the viewer. So there are three kinds of visibility. One is completely visible, another is partially visible, and the last one is completely invisible. Okay. So there are three types of visibility we have in clipping operation. One is complete visibility, another is partial visibility, and the third one is complete invisibility, which is completely invisible. Okay. Is it clear to all of you?
Yes, sir.
Okay. So now we will go for the procedure, how we can do this line clipping operations, how we can proceed with this line clipping algorithm. We will see here the procedure for line clipping operations. So we have to, as with these images, we can see here the first step is test line segment to determine if it resides completely inside clipping window or not. Test line segment to determine if it resides completely inside clipping window or not. Okay. So as what I have said earlier also, we have this window frame. We have this window frame means we have the coordinate of this 4-axis point. As we can see here, it is a rectangular specified region or rectangular window frame. We have 4-axis points. We have 4-axis points of this window frame. Okay, and we know the coordinates of this 4-axis point of the window frame. Now all the lines given to you, for determining or for applying the clipping operation, you have the coordinates of the end point of all of these lines like P1, P2, P3, P4, P5, P6 up to P10. you have the coordinate of all of these endpoints of the straight lines. So what you have in your hand, one is the coordinates of the 4 axis point of the rectangular window frame. You know the coordinates of 4 axis points of the rectangular window frame. And what else you know? You know the endpoint coordinate values. The endpoint coordinate values of all the straight lines given to you. Now you have to just calculate. First you have to test that. First you have to test that the endpoints are within this window frame or not. The given endpoints are within the rectangular window frame or not. How you will check that? Just now I have told you in this way, point clipping. That is, if the coordinate of an endpoint is within the range of XWL, XWH and YWL, YWH, then that particular point is inside the window frame, inside this rectangular window frame. Say we are considering the point P1 and we are considering the point P9. Consider these 2 points. Okay, consider these 2 lines actually. Okay, consider these 2 lines, P1, P2 and P9, P10. Okay, so these 2 lines, how many endpoints have? These 2 lines have how many endpoints? Tell me. 4, right? These 2 lines have 4 endpoints, P1, P2 and P9, P10. Now we will test that. We will test individually all of these points. First we will go for P1 and P2. Okay, we will check the coordinate of P1, point P1. That is, if the coordinate of point P1 is x1 and y1, then we have to check that x1 is within the range of XWL and XWH. If it is within the range of XWL and XWH, and for y1, if it is within the range of YWL and YWH, then the point P1 will be inside the window frame. Just like that, we will check point P2, point P9 and point P10. And as you can see here, the result will be that point P1, for point P1 and P2, both the points will be within the range of XWL and XWH and YWL, YWH. So that both of these points P1 and P2 are completely inside the window frame. So we can easily say that P1, P2, this straight line is completely within the window frame and completely visible to the viewer. And in other hand, when we check point P1 and P10, for these 2 points, according to this example, we can see here point P9 and P10. If we check these 2 points, point P9 and P10, we will see that the coordinate x coordinate is not within the range of XWL, XWH, and y coordinate is also not within the range of YWL and YWH. So we can say that both the points P9 and P10 is outside the window frame, and the straight line is completely invisible. But here is another question will arise. Consider the line P7, P8. Okay. Here also you will see, just like P9 and P10, both the points P7 and P8, according to the point clipping algorithm, both the points P7 and P8 are completely outside the rectangular window frame, but some portion of this line is passing through the window, frame. So this straight line P7 and P8 is not completely invisible to the viewer like P9 and P10. A little portion of this straight line will be visible, which is inside the window frame, which is passing through the window frame, as you can see here in the after image. So we can't say that if both the endpoints of the straight line like P9 and P10, we can't say that if both the endpoints are outside the window frame, then the total straight line is outside the window frame or completely invisible. We can't say that, right? Is it true?
Yes, sir.
Yes. So we can't say that. We have to check that any portion, maybe the end point of the line is outside the window, but some portion of the line can pass through the window frame, so that a little portion of that straight line will be visible within the window frame to the viewer. So we have to check that. So how we can check this? Come to the second point. Test to see if it is completely outside. So in the first point, as you can see here, in the first point we have checked that test line segment to determine if it resides completely inside the clipping window or not. That is the case of P1, P2, the line P1, P2, which is completely inside the clipping window. So how we can check that? We will check that P1 and P2, these two end point of the straight line, these 2 points are completely inside the clipping window or not. If both the endpoints are completely inside the clipping window, then by closing our eyes, we can say that the total line is completely inside the window. There is no other option. Okay. So it is clear. It is very much clear to all of us that if both the endpoints of the line is completely within the clipping window, then the total line will be also completely inside the clipping window. So no problem for that. Now come to the next point, which I have discussed. That is, if both the endpoints of a straight line is outside the window, then also we can't say that the total straight line is completely invisible, completely outside the window, because some part of this line can pass through the rectangular clipping window, and that portion will be visible to the viewer or will be partially visible. So how we can test this thing? Okay, test to see if it is completely outside. When we have two endpoints, okay, when we have two endpoints of a line in our hand, and we have all the 4 axis points, of that particular window, of that particular clipping window. So the endpoints which are not, listen very carefully, that is the endpoints which are not completely inside the clipping region, which are not completely inside the clipping window. For these straight lines, we have to check that if there is any intersection points, if there are any intersection points of that straight line with any 4 sides of the clipping window. Is it okay, or I will repeat? Is it okay, or I will repeat?
Okay, sir.
Okay, for the others, I am just repeating this thing once more. That is, we will check with the endpoints. We will check with the endpoint coordinate of each and every line to find out that if this line is completely inside the rectangular window or completely outside the rectangular window or partially inside the rectangular window. According to the endpoint coordinate, we are going to check this. So the first point is that according to the line clipping procedure, as you can see in the notes, the first checking is that test line segment to determine if it resides completely inside the clipping window or not. That is for the case of line P1 and P2. Line P1, P2. Okay. We will check all the endpoints like P1, P2, P3, P4, P5, P6. All the endpoints we will check according to the four axis points of the rectangular window. That is XWL, XWH, YWL, YWH. Okay. Now we will check that if endpoints, the coordinates of the endpoint for a particular line, if the coordinate value of the endpoints of a particular line, both the endpoint coordinates are completely within the rectangular clipping region, like P1 and P2. Okay, then the total straight line P1, P2 will be completely within the rectangular window frame. Okay, how we will check that? Say for P1 and P2, P1 has a coordinate, say x1, y1, and P2 has a coordinate, say x2, y2. Now we will check that first for P1. So the coordinate is x1, y1. We will check that if x1 is within the range of xwl, xwh. And we will check that if y1 is within the range of YWL and YWH. If in both the cases x1 and y1, these are within the range of XWL, XWH and YWL, YWH, then the point P1 will be inside the window frame. Again, we will check the same thing for the point P2, that is x2 and y2 is within the range of XWL, XWH and YWL, YWH. If x2 and y2 is within these two ranges, then we will say that point P2 is also within the window coordinate frame. So both the points P1 and P2 are completely inside the window coordinate frame. So we can say that P1, P2, this line is completely within the window frame. No problem for that. Okay, is it okay for all of you? Is it clear to all of you?
Yes, sir.
Okay, next, for the other endpoints like P3, P4, P5, P6, P7, P8 and P9, P10. For all of these other endpoint, we will just the same way like P1 and P2, we will check the coordinates of all of these endpoints so that it is completely within the window or not. Say for P3, P4, we will say that both the endpoints P3 and P4 are completely outside the window. Okay, completely outside the window. For P5, P6, we will see that P5 is outside the window, but P6 is inside the window. So P5 and P6, this straight line will be partially visible. For P3, P4, both the points are outside the window, but we can't say it is completely outside window till now. Okay, we need another checking. P7 and P8, for these two endpoints, P7 and P8, both the points are outside window, but we can see here this straight line is passing through the window frame. So some portion of the straight line will be inside the window and as well as visible to the user also, visible to the viewer also. And for P9 and P10, again both of these endpoints are outside the window, but we can't say that this total straight line, the whole straight line, is completely invisible or not. We need another checking. So what is that checking? For this kind of points, for this kind of endpoints, or for this kind of straight lines, okay, for this kind of straight lines which have endpoints outside the clipping window, we have to check that these straight lines have any intersection points. These straight lines have any intersection points with the four sides of the rectangular clipping window or not. Can you understand what I am trying to say? Can you understand what I am trying to say? We have to check that for these particular straight lines whose endpoints are completely outside the window region, we have to check that these straight lines have any intersection points with any of the four sides of the window or not. Can you understand?
Yes, sir.
Okay. Why the others are quiet? Why the others are so quiet? Only Anokhi is responding. What about the others? All of you? Can you understand all of this? Can you understand these things? What about the
Yes,
others?
sir. Yes, sir.
Okay. Okay. So just a minute. Yes. So we have to check that these straight lines whose endpoints are completely outside this window frame, these straight lines have any intersection point with the window frame or not. Any intersection points of the window frame or not. Okay, we have to check this thing. So how we can check this thing? Tell me how we can check that two straight lines are crossing each other. Do you know what is the condition for that? What is the condition for getting the intersection points within two straight lines? Can you recall this? You have studied it already in your 11-12 trigonometry. What is the condition for intersection of two straight lines?
Having two
Any one of
common
you?
points.
Yes, tell me, Anaki.
Having common points at the point of intersection.
Absolutely, exactly. Very good. Common point. If there is any common point in between these two straight lines, then we can say that these two straight lines are intersecting with each other. Absolutely correct. Okay. So we have all the coordinate points. We have all the coordinate points of all the endpoints of the straight line, and we have the coordinates of the four axis point of the window frame. So using these coordinates, we can easily find out that these straight lines like P3, P4, P5, P6, P7, P8, and P9, P10, for all of these straight lines whose endpoints are completely or partially outside the window frame, for these straight lines, we will check according to their endpoint coordinate value. We will check that it is intersecting. These straight lines are intersecting with the four sides of the window frame or not. Okay, just like for an example, take the straight line P7, P8. We have the endpoint coordinate of this straight line. One is P7 and another is P8, and we have the four axis point of this window frame, that is XWL, XWL, YWL, XWH, YWH. That is the four axis point, that is the axis point coordinate of this window frame. So according to this coordinate and the coordinates of P7 and P8 point, we can easily find out that this straight line has two intersection points. Two intersection points with this window frame. One is here and another is here. It has two intersection points. One is here and another is here. Okay, so we can easily find out that according to the equation of this straight line P7, P8, with the equation of the straight line of this window frame or any side of this window frame, we can easily find out that this straight line P7 P8 has two intersection points with two sides of this window frame. Two sides of this window frame. Okay, so what Anokhi has said that the same value of the points, the same value of the points of these same coordinate value of the points of these three straight lines. Okay, we can find out that which are the intersection points. One is here and another is here. Only this part, okay, only this part will be visible or will be inside the window frame, and this part will be visible to the user. So how we are going to determine it? According to the equation, according to the equation of the straight line P7 P8, it will be compared. This equation will be compared with the equation of the four side of the window frame. We will compare the equation of the straight line P7 P8 with the equation of the four sides of the window frame, where we will get a match or where we will get a same point. What Anokhi is trying to say, we will check or we will compare the equation of the straight line P7 P8 with the equation of the four side of the window frame. The equation of the four sides of the window frame we will compare, okay, with the equation of the straight line P7 P8, where in which side individually we will compare. Individually we will compare the equation of the straight line P7 P8 with the four sides of the window frame, where we will get a match or where we will get a same intersection point or where we will get a match. There we will find one intersection point. In this way, for this particular example, we will get two intersection points with two sides of this window frame with this straight line P7 P8. Okay, and whenever we will get these 2 points, these 2 points will be clipped just like this after image. You can see here in this after image, you can see here this straight line P7 P8 has been clipped into P7 dash to P8 dash. That is the clipped portion. These are the intersection points. P7 dash is one intersection point with one side of the window frame, and P8 dash is another intersection point with another side of the window frame. And this P7 dash P8 dash, this is the portion which is partially visible within the window frame as well as to the viewer also. So this is the second step. Here we can see test to see if it is completely outside or not. Okay, is it clear to all of you? Please tell me.
Yes, sir.
Okay. The third, what I have told you just now. The third point, what I have told you just now. Second point is test to see if it is completely outside. Example is this P9, P10 straight line, P3, P4 straight line. All of these are the example of completely outside straight lines. You can see here in after image, these two straight lines are completely invisible. These two straight lines are completely clipped out because they are completely outside the window frame. And the third point, if we are unable to tell, যেটা আমি বলছিলাম, what I'm trying to say, that if we are unable to tell, we can't say if these two endpoints like P9, P10, P3, P4, P7, P8, if all of these both the endpoints of a straight line are outside the window frame, then also we can't say that this straight line is totally outside the window frame or totally invisible. Example is, you can see here P7 P8, যেটা আমি এক্ষুনি বললাম, what I am just now I have said. Okay, so if we are unable to tell that, perform intersection test. Perform intersection test. Okay, what I have described just now. So what is this intersection test? I have explained you already. That is inside outside test. Check both the endpoints. If both P1 and P2 are within boundary, the line is saved. If both endpoints are outside, drop the line segment. Remaining may require calculation of multiple interactions. What I have said you, what I have tried to say you, that is for P7 P8 and for P5 P6. For P5 P6 also, you can see here one point, that is P6. This is completely inside the window frame, and the another point P5, that is completely outside the window frame. So obviously there will be an intersection. One point is inside and another point is outside. So obviously this straight line P5 P6 will have an intersection with the side of the window frame, and we can see here this intersection point is P5 dashed. This intersection point is P5 dashed, and the line has been clipped up to P5 dash to P6. Only this portion is inside the window frame, and that is visible to the viewer. Okay, is it okay to all of you? Is it clear?
Yes, sir.
Okay. So this is basically the line clipping algorithm. The first clipping algorithm we have studied, the line clipping algorithm based on the intersection test and the outside inside test. This line clipping algorithm, the first algorithm of clipping, the first algorithm for line clipping, this is the naive algorithm, is basically based on two approaches. One is inside outside test, that is the point is inside the window frame or outside the window frame, that is called inside outside test. And the second approach is intersection test. If the point is outside the window frame, then we have to check there is any intersection or not. That straight line has any intersection with any side of the window frame or not. If there is any intersection, then the straight line will be partially visible to the viewer, because that intersection points, in between that intersection points, that portion of the straight line will be inside the window frame, and that will be partially visible to the to the viewer. Okay, so this is the basic algorithm you have already studied, a line clipping algorithm based on inside outside testing and intersection test. So any query, any problem up to this line clipping algorithm, you can tell me. If there is any query up to this line clipping algorithm, please tell me. If anyone have any query of this line clipping algorithm, please tell me. Is it okay to all of you?
Yes, sir.
Okay, what about the others? Lalu, Rizwan, Suparna?
Yes, sir.
Is it okay to all of you? Hello?
Yes, sir.
Yes, sir.
Okay, okay. Okay, so should we continue to another algorithm, or it will be in the next class? What do you say? What do you say? Should we continue with another algorithm, or it will be in the next class?
So next class.
Next class. Okay.
Yes, sir.
Anokhi, Lalu, Suparna.
Next class, sir.
Next class. Okay. So only in today's class, I do not know why a few very low attendance is here. We have already calculated attendance because as you know that this report has been uploaded to university portal from your side also and from our side also. There is a student portal by which you have to upload your online activity report to university portal, and from faculty side also we have to upload the total class report to the university portal. So that's why we have collected the attendance for each and every class, because we have to upload this attendance according to your roll number to the university portal. Okay, so today's attendance is very low. Only Anoki, Lalu, Rizwan, and Suporna is there. So I am giving attendance to all of them. And this video lecture will be only available to those students who have attended the class, not to the others. Just convey this message to your friends. Okay.
Okay, sir.
Okay, sir.
Okay, thank you very much. And one more thing, that is, just a minute. Yes. Okay. Okay, so thank you very much. Next day we will meet again on Tuesday at the same time, that is from 12 p.m. For computer graphics class, and tomorrow we have AI classes. So those who have AI as elective paper, you just convey this message to all of those friends also. I will, from my side, I will also share the Microsoft Team joining link to all of them, just like today or just like every day. Okay, so thank you very much. Thank you very much to all of you.
Thank you, sir.
Okay, thank you.